Week 9, lesson 2. Okay, so I'm going to teach you how to graph rational functions a different way than you learned back in week 8. All right, and so what it's going to depend on is, can you graph something that's not a rational function? Okay, so let's take a look at this example, for example. Yeah, that makes a whole lot of sense, but sorry, it's been a long quarter. Anyway, so y equals x is just a line, right? For every y value, you get the exact same x value. So it's this line, right? You know what the slope is, you know what the y-intercept, you know everything about this thing. Okay, now to graph the reciprocal of this, right? Because that's what is being asked over here. I want the reciprocal of this graph. So what I'm going to do is I'm going to take every one of those dots, okay, every one of those y values, and I'm going to take the reciprocal. So like this one, right? That is what, -5? 1, 2, 3, 4. Oh, I stand correct, -6. The reciprocal of -6 is -1/6. And the reciprocal of this one will be -1/5. And the reciprocal of this one will be -1/4. And -1/3. And -1/2. And -1. And this is 0. And the reciprocal of 0 doesn't exist. So that's why there's an asymptote right here. Now this is where I'm going to have to kind of zoom in a little bit. So let's take a look at maybe this point right here. I think you would agree that that's probably 1/2, right? That y value right there is 1/2. So if I come over here and I try to graph the reciprocal of sorry, that I should have said -1/2. I end up with -2. And then if I come back over here and I get the smaller this gets, right? As these get smaller and closer to 0, on the other graph, these reciprocals get bigger, right? The reciprocal of a small number is a big number and vice versa. So these end up getting further and further and further away. So this side looks like this. And then likewise, we can kind of back it in from the other direction. If I look at this number here, that's 6. So the reciprocal of that is 1/6, 1/5, 1/4, 1/3, 1/2, 1. And again, as I get closer and closer and these get smaller and smaller and smaller, these over here on this graph get bigger and, bigger, 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 bigger. Okay, so now let's take a look at the domain and the range. Now on this first one, I'm going to go ahead and do it in interval notation, but on the other ones, I'm not. Okay, and the reason I want you to see this is that the domain, right, the domain goes this keeps going and going and going and going, goes all the way to -infinity, and then it gets close to 0, but then it jumps, right? This dotted line, which is an asymptote, nothing exists at 0. So we're going to use this U, which means union, and then it picks up at 0 again, but never actually touches it all the way to infinity. Okay, and then the range is the same, believe it or not. The range goes from -infinity all the way to infinity with a jump, right, with this union part, because it jumps at 0, because this never is going to come over the top of that. All right, so let's try a different one. Okay, trying a different one. Let's try the second one. Okay, so over here on the left, I have this parabola that I need to graph, which is x times x minus 4. So I know I have zeros at 0 and at 1, 2, 3, 4, which means I have an asymptote in the middle, right? Asymptote right here. Over 2, down 1, 2, 3. Here's my vertex. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've got some actual nice looking ordered pairs that I can take reciprocals of to graph the next one to the right. Okay, so let me switch colors. Okay, so if I'm trying to graph this one, The first thing I'm going to do is I'm going to take the reciprocal of all of those ordered pairs that I just graphed on the left one. So if I do this one, that's up 1, 2, 3, 4, 5. So I have a reciprocal at 1/5. This 0 value is going to be an asymptote. The reciprocal here of -3 is going to be -1/3. The reciprocal here, right, at -4 is going to be 1/4. Here's another -1/3. This will be an asymptote. 1, 2, 3, 4, asymptote. And this value up here is going to have a reciprocal that looks like this. Okay. Now, again, you kind of have to, the hardest part of this is in between, let's say, from here to here. All right, you need to recognize that on this graph on the left, those numbers are getting smaller, right? The y values are getting smaller. But that means over here on the right, in that same little interval, they're getting bigger, right? They're getting bigger. All right, and then over here, again, I'll highlight in a different color. Here, as these are getting bigger and bigger and bigger from that dot, for the reciprocal, they're getting smaller and smaller and smaller. Okay, so the same thing happens here. All right, what depends on if you're getting smaller or bigger on the original graph. Same thing happens over here. Okay, so you have to think about what's happening here in order to be able to graph the reciprocal. Now, as far as the domain of this picture, we're not going to use interval notation here. We're going to say x cannot equal 0 and x cannot equal 4. Okay, but x can equal anything else. And as far as the range, the y is going to be greater than 0 and y is going to be, right, because it never goes past that line. And y has to be less than or equal to 1/4 because that is the highest spot right there. It's 1/4 because on the original graph that you can say, sorry, -1/4, because this is -4. All right, let's move this up, see if we can do the third. Okay, so for this on the left, this is a downward facing parabola. Okay, it's not in vertex form, and it doesn't seem to be factorable. Well, maybe it's factorable, but you know, I'll just do it the other way. I know to do the axis of symmetry, it's -b/2a. In this case, -4/2 times -1 or 2. Here's my axis of symmetry. I know my y-intercept is at -3, which means I know I have another ordered pair right there. 1, 2, 1, 2, 3, 4. Here's my vertex. It is downward facing. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got, again, a bunch of really nice looking dots that I can take reciprocals of. Now over here on the right, if you're thinking to yourself, this doesn't quite look right because I now have a negative on top and these signs do not look the same as these. What's happened is we've taken out the negative out of the bottom and put it on the top. So it definitely is the reciprocal. So let me go ahead and put, for this dot and this dot, let me put in my asymptotes because you can't take the reciprocal of 0. All right, for this point right here, which is up 1, the reciprocal of that is 1. All right, and slightly to the left and slightly to the right, these numbers are getting smaller, which means on this picture on the right, they are getting bigger, right? Keep in mind, the reciprocal of small numbers are large numbers. Okay, and then here, these 2 points, which are at -3, are going to give me -1/3. These that are down here at 1, 2, 3, 4, 5, 6, 7, 8 are going to be -1/8. There they are. And keep in mind here, these are getting smaller, right? They are approaching 0. They're getting smaller, which means these are getting larger or further away from 0 in the negative direction. Okay, so as far as the domain, x cannot equal 1 and x cannot equal 3. Those are the two vertical asymptotes. For the range, up on top it bottoms out right here at the value of 1. So y has to be greater than or equal to 1. And then there's an asymptote. It's not easy to see, but y has to be less than 0. All right, there's a second page to this. Okay, so for this one, let's take a look for part A as to what this looks like when you graph it. Okay, so you know it's a square root function. You know that it's been moved to the right. So it kind of looks like that. Sorry about the change of color. Okay, so then the reciprocal of that, right, if we're just trying to take a look at what that looks like, this point here, which is at 0, the reciprocal of that doesn't exist. So there's an asymptote right there. All right, and then let's say this point right here, that might be 1, so there'd be another 1. These numbers here in between are getting smaller, which means the reciprocal is getting bigger, and these are getting larger, which means this is getting smaller. So it looks something like this. So that makes the domain x greater than 2, right? And the range is y values that are greater than 0. And then, let's move this up. For this last one, if you take a look, and I may not graph this whole thing, I know that this denominator, the whole thing, cannot equal 0, all right? And I also know that under the radical can't be negative. All right, so if I factored what's under the radical, I get 3x minus 2 and x plus 1, right? Keep in mind that's under the radical, okay? But there's a couple things that would happen here. Like, how do I explain this? This is a parabola. Under the radical, it's a parabola, all right? And it has zeros based on the fact that it factors like this at -1 and at positive 2/3, right? That's where the zeros are. So, and since it can't be negative, this part of the parabola can't exist. All right? Right? Think about this. Those are the zeros. That's negative. So as far as the domain, I'm allowed to have these values where x is less than -1, and I'm allowed to have these values where x is greater than 2/3. Okay? And as long as those are the domains, then the range will be that y is greater than 0. All right, because again, if this denominator is never going to be negative, then the entire picture is going to be positive.